Hey there! Welcome back to the channel. In today's video, you'll understand what an insertion sort is, how to code it from scratch, and its time complexity. If you're new here, my name is Teresa. I'm a software engineer, and on this channel I post coding tutorials like this one as well as some casual daily life vlogs. Let's begin. So what is an insertion sort? The insertion sort is similar to how we sort things. Card, for example. We sort it by finding the element that is just smaller than the current element in the sorted part, then we move the current element next to that element. As you can see here in the animation, 2 is just less than 3. Therefore, we move the element 3 to the position next to 2. So where do we start? We know that we have to go through all the elements in the array, so let's write down loop through the array. Next, we have to find the element that is just smaller than the current element, and we can do this by going backwards from the current position to the beginning of the array, and then find the first element that is smaller than the current one. Once we've found where to put the element, then we shift some parts of the array to the right by 1, so that the current element can fit in. Let's visualize how this is going to work. Let's say that we have the array 1, 2, 4, 5, 3, and the current position is the last one, number 3. To find the element that's just smaller than the current one, we simply move backwards and find the first element that is smaller than 3, and that element would be 2. But while we're finding, we can also shift the element to the right at the same time. So when we look at 5, 5 is larger than the current one, so we copy it to the right. So the array would actually be something like 1, 2, 4, 5, 5. Then when we compare 3 with 4, 4 is still larger than 3. So we do the same thing. Now the array would be 1, 2, 4, 4, 5. Then when we compare 3 and 2, 2 is not larger than 3. So we stop looking. At this point, the array is 1, 2, 4, 4, 5. Now once the loop stops, we can simply put 3 at the position before the loop stopped, which will give us 1, 2, 3, 4, 5. Now let's try writing this down in a more concrete way. First, we need a for loop that will loop through the entire array. So for each element, and I'm just going to call this element I. Now we have to save the current element so that we can swap it later on at the end of the second loop. So current equals element I. Then we have another loop inside of here going backwards, and stop when it reaches 0 or when the element is smaller than the current one, and we're just going to call this element j. Inside here, we're going to copy element j to element j plus 1, so element j plus 1 equals element j. Then we decrement j by 1 to move to the left of the array. Afterwards, when the loop is over, we're going to set element j plus 1 equals to I. And this is all for our pseudocode. Next, let's try coding this up. I'm just going to implement this in Python as usual, and I'm going to have a function called sort that takes in a variable array r. I'll also have another variable n, which is going to be set to the length of the array. Now let's get into the meat. First, we have to loop through the array, so for I in range n. Next, we need a variable that will save the current element, so current equals r at I. Now it's the second loop. Instead of using a for loop, I'm just going to use a while loop this time. And we need an indexer j. We'll initially set it to I minus 1 and decrement it each time inside the loop. While j is larger or equals to 0 and current is less than array at j, we're going to set element j plus 1 to j, and then decrement j by 1. Now, once the loop is over, we will set array at j plus 1 to current. And we need the plus 1 here because j is going to point to the element that is smaller than the current one, so we need to add plus 1 to place the current element to the position next to it. Let's test this out. I'm just going to give it a random array, and here you go, a sorted array. For the time complexity, I normally look at the best case and the worst case only. For the best case, if the array is sorted, the algorithm will loop at least n times here, but the second loop is going to be a constant because it's going to compare the element I minus 1 and breaks the loop right away. Therefore, we have an O1 inside of an ON. So the time complexity for the best case is an ON. What about the worst case? For the worst case, we have an n here, and this is going to be n minus I times, but since it's still relying on I, we're just going to call it n. And n iteration inside of an n iteration is going to be n squared, therefore the time complexity for the worst case is O(n) squared. And this is all for the insertion sort. If you like this video, you might be interested in the playlist of sorting algorithms that I've created. Please stay tuned for the next one in the series. See you again next week. Bye!